Okay, so in the last lecture, good morning to everybody. In the last lecture, we started the third chapter, inode, that is internal representation of files. And under that, we started the first point, that is inodes. We were talking about inodes. So we have seen two types of inodes are present in the system. One is called as a in-core inode, another is called as a disk inode. So we discussed in the last lecture about the disk inode, right? We discussed about the disk inode in detail. So disk inode is having total 7 fields. So these 7 fields we discussed. First one is the file owner identifier. Second one is the file type. Third one is the file access permissions. Fourth one is file access times. Next, number of links, table of contents, and file size. And we discussed sample disk inode with the help of this example. So this is the sample disk inode over here. Owner of that file is MJB. MJB is name of the owner. OS, it is name of the group. So 3 types of people are there in Unix: owner, group, and user. So accordingly, the names are given over here. Type of file is regular file. Permissions with respect to this file are RWX with respect to owner, R-X with respect to group, and R-X with respect to user. After that, the 3 access times are there. 3 times, that is access time of the file, modification time of the file, and inode modification time. Then size of the file and addresses, exactly on which data block the file is stored. So addresses of all the data blocks depending upon the size of file that is stored as a part of disk addresses. It is also called as a table of contents, right? So this is the sample disk inode. Now we'll proceed further about in-core inode. Okay, so I said that inode exists in 2 formats. Whenever it will be accessed at kernel level from the hardware level, so it is called as a in-core inode. And whenever it will be on the hardware level, it is called as a disk inode. जोपर्यंत inode disk वर असतो त्याला disk inode म्हणतोय आपण. आणि जेव्हा एखादी फाईल ओपन होते, म्हणजेच जेव्हा disk inode कर्नल लेवलला ऍक्सेस केला जातो त्याला in-core inode म्हणतात. So now we are discussing about in-core inode. The in-core copy of the inode contains the following fields in addition to the fields of disk inode. जे in-core inode मध्ये कुठले कुठले fields आहेत, तर in-core inode consists of all the fields of disk inode plus some additional fields. So whatever 7 fields of disk inode we discussed, all these 7 fields are also applicable to in-core inode. So in-core inode consists of these 7 plus 5 more. So total almost 7 plus 5, 12 fields are there in case of in-core inode. In-core inode मध्ये total 12 field आहेत. त्या 12 field पैकी 7 field आपण disk inode मध्ये डिस्कस केलेले आहेत. त्यामुळं जे काही 7 field आहेत पहिले 1 to 7, these are common for disk inode as well as in-core inode. So disk inode we discussed total 7 fields. Disk inode चे 7 field आहेत आणि in-core inode चे 7 बरोबर अजून 5 additional fields आहेत. Okay, so the in-core copy of the inode contains the following fields in addition. I have underlined the word in addition to the fields of the disk inode. Disk inode चे जे काही 7 fields आहेत ते 7 ही fields in-core inode मध्ये येतात. त्या 7 बरोबर अजून काही additional fields आहेत. So we are going to discuss these additional fields. So this will be the 8th field in case of in-core inode. This will be the 8th field additional. First one, the status of in-core inode. The status of in-core inode. So we discuss status of buffer cache. We discuss status of buffer. Two different types of status were there. In the same fashion, in-core inode is also having its own status. First status, inode is locked. Either inode will be locked or unlocked. जेव्हा एखादी फाईल ऍक्सेस केली जाते हार्ड डिस्क वरून कर्नल लेवलला, फाईल ऍक्सेस करायच्या अगोदर त्याचा आयनोड ऍक्सेस केला जातो. सो जस्ट टू ऍक्सेस द ऍड्रेस ऑफ द फाईल, कारण आयनोड मध्ये फाईलचा ऍड्रेस दिलेला असतो. सो फाईल जर ओपन करायची असेल तर कर्नल काय करतो, पहिल्यांदा आयनोड ऍक्सेस करतो आणि आयनोड मधला डिस्क ऍड्रेस फील्ड ऍक्सेस करतो. देन कर्नल इज एबल टू ऍक्सेस द file contents. So whenever inode is accessed, either for reading purpose or writing purpose, it will be locked. So the first status is inode is locked. Either it will be locked or unlocked. A second status, a process is waiting for the inode to become unlocked. So some of the processes may be there. Some of the processes may be there. They also want to access the same inode. For example, readers. So n number of readers may be there. एकच फाईल आपण एकापेक्षा जास्त विंडोज मध्ये ओपन करू शकतो. एकच फाईल आपण नोटपॅड मध्ये ओपन करू शकतो. तीच फाईल आपण वर्डपॅड मध्ये ओपन करू शकतो. तीच फाईल आपण सी एडिटर मध्ये ओपन करतो. लाईक दॅट ऑनवर्ड्स. We are able to open same file in more than one windows. So whenever the file is opening, so its inode will be locked. And whenever the opening is over, जेव्हा फाईल ओपन करायचं complete होतं, so again inode will be get released, unlocked, and again it will be locked whenever it will be access to the next time. So like that, a process is waiting for the inode to become unlocked. There may be number of processes, those who are waiting for the inode to become unlocked. This is another status of the inode, in-core inode. Right now we are talking about in-core inode. In-core inode बद्दल बोलतोय आपण. In-core inode मध्ये पण टोटल 12 फील्ड आहेत. त्या 12 फील्ड मध्ये 7 फील्ड आपण ऑलरेडी डिस्कस केलेले आहेत. का तर हे 7 फील्ड in-core inode बरोबरच disk inode चे पण फील्ड्स आहेत. So both inodes, they are having same 7 fields, common 7 fields. So some additional fields we are discussing in case of in-core inode. So that's why I said that this is the 8th field in case of in-core inode. So 8th field is status of the in-core inode. Either the in-core inode will be locked, it will be, or processes may be waiting for that inode to become unlocked. The in-core representation of the inode differs from the disk copy as a result of a change to the data in the inode. Listen carefully to understand these two status. एक status काय म्हणतात, the in-core representation of the inode differs from the disk copy. inode ची ऑलरेडी डिस्क वर एक कॉपी आहे, ती कॉपी आपण कर्नल लेवलला ऍक्सेस करतोय. So it is differing from the disk copy. Why? As a result of change to the data in the inode. Change to the data in the inode म्हणजे डिस्क आयनोड मध्ये जो डेटा आहे त्याच्यापेक्षा वेगळा डेटा इन कोर आयनोड मध्ये आहे. सो वी आर चेंजिंग द आयनोड. वी आर चेंजिंग द आयनोड. फॉर एक्झाम्पल, जर आपण एखाद्या फाईलचे परमिशन चेंज केल्या, जर आपण एखाद्या फाईलच्या परमिशन चेंज केल्या, जर अगोदर सपोज ओनरला रीड राईट एक्झिक्यूट परमिशन्स असतील, ग्रुपला रीड डॅश एक्स परमिशन्स असतील, आणि जर आपण त्या ग्रुपच्या परमिशन्स रीड राईट एक्स केल्या, आर डॅश एक्स च्या ऐवजी आर डब्ल्यू एक्स केल्या, सो इट मीन्स inode of that file is get changed. So how to change the permissions? Again, we have to execute the chmod command. chmod command ना आपण फाईलच्या परमिशन चेंज करू शकतो. म्हणजे फाईल चेंज करत नाहीये, फाईलचे कंटेंट्स चेंज करत नाहीये, पण फाईलच्या परमिशन चेंज करू शकतो. Or you may access the same file more than once. For example, आता ऍक्सेस केली तर त्याचा ऍक्सेस टाइम असेल 11:15. थोड्या वेळानंतर ऍक्सेस केली ती फाईल रीडिंग साठी तर त्याचा ऍक्सेस टाइम असणार आहे 11:20. इट मीन्स इन शॉर्ट आय जस्ट वॉन्ट टू से दॅट व्हेनेवर वी आर ऍक्सेसिंग द फाईल, इट्स ऍक्सेस टाइम विल बी गेट चेंज्ड. आपण फाईलचे कंटेंट चेंज करत नाहीये, पण फाईल ऍक्सेस केली की ऑटोमॅटिकली याचा आयनोड चेंज होतो. बिकॉज वन ऑफ द फील्ड इन द आयनोड इज access time, file access time. So if we access the file, so inode will get changed. So like that, the in-core representation, in-core inode differs from the disk inode as a result of change to the data in the inode. inode मध्ये चेंज झाल्यामुळे, inode च्या डेटा मध्ये चेंज झाल्यामुळे in-core copy disk copy पेक्षा different आहे. This is one of the status. Next status, the in-core representation of the file differs from the disk copy as a result of a change to the file data. जर मी फाईलचे कंटेंट्स अपडेट केले, फाईल मध्ये सपोज 5 बाइट्स असतील आणि मी अजून 5 बाइट ऍड केले, म्हणजे फाईलची साईज किती झाली 10 बाइट्स. सो व्हाट आय डन, आय इन्सर्टेड समथिंग इनसाइड द फाईल, आय अपडेटेड द फाईल. सो ऍज अ रिझल्ट ऑफ दॅट अपडेशन, फाईल साईज गेट चेंज्ड. So if we change file data, automatically its size will be get changed. So as size is going to be changed and size is one of the field of inode, so inode is also going to be changed, right? File चे content change केले की inode change होतो. तसंच inode चे पण काही contents आपण change करू शकतो without changing the file contents. So like that, one status is indicating that the in-core representation of the inode differs from the disk copy as a result of a change to the data in the inode. And the second status tells that the in-core representation of the file differs from the disk copy as a result of a change to the file data. एकदा आपण फाईलचा डेटा चेंज केलाय त्यामुळे आयनोड इन कोर कॉपी डिफर झालेली आहे आणि एकदा आपण आयनोडचा डेटा चेंज केलाय त्यामुळे इन कोर कॉपी डिफर झालेली आहे. So these are two more status, two most important status with respect to in core inode. And the last status is the file is a mount point. So file is a mount point. So sometimes file inode is also acting as a mount point. So detail about mounting we are going to discuss in fourth chapter. So for a while, just keep in mind that mount point in the sense. So the inode will be busy in mounting, that is accessing other file system from the current file system. It is the concept of mounting. So file is a mount point. So these are the total 5 status with respect to the in-core inode. So all of you note it down. This is the 8th field. So you have to write in-core inode. You have to write in-core inode, and in that fields of in-core inode. So write first 7 fields as it is, which we discussed in case of disk inode. First one will be the same fields are applicable for in-core inode also, but some additional fields. So again, in case of in-core inode, first field will be file owner identifier, second field will be file type. I hope you are noting it down. First will be file owner identifier, second will be file type, third will be file access permissions, fourth will be file access times, fifth will be number of links, sixth will be table of contents, seventh will be file size, and now eighth is status of in-core inode. Status of in-core inode. So most of all the times, short note is asked on status. So write a short note on status of an in-core inode. So as total 5 status are there, question will be asked for 5 marks. Status of in-core inode. All of you note it down. Status of in-core inode. All of you note it down. First status, inode is locked. Second status, a process is waiting for the inode to become unlocked. Third status, the in-core representation of the inode differs from the disk copy as a result of change to the data in the inode. Next status, the in-core representation of the file differs from the disk copy as a result of a change to the file data. The last status, the file is a mount point. Sometimes that inode will be treated as a mount point during mounting. Mounting is nothing but temporarily accessing part of other file system to current file system. Okay, is it over? Yes, students, are you writing? तेजल शुरू से.
Yes, ma'am.
Are you noting it down?
Yes, ma'am.
Okay. Is it over? Okay, so this is about status of in-core inode. So there are total 5 status. Either inode will be locked or process may be waiting for the inode to become unlocked. The in-core representation of the inode differs from the disk copy as a result of change to the data in the inode. The in-core representation of the file differs from the disk copy as a result of a change to the file data. And the last one, file is a mount point. Okay, so next, that is ninth field under in-core inode, logical device number of the file system that contains the file. So we discussed about logical device number in case of buffer header. So this is nothing but the logical device number. It is the file system number. That is whether we have booted, whether we are accessing the file of Linux or Windows. So logical device number represents unique identity of the file system, whether the file system is related to Unix or Windows, whether the file system is related to Windows or Unix. So this is nothing but the identification of the file system. So the logical device number of the file system that contains the file. फाईल आपण कुठल्या ऑपरेटिंग सिस्टीम मधून ऍक्सेस करतोय, लिनक्स मधून ऍक्सेस करतोय का विंडोज मधून ऍक्सेस करतोय. सो दॅट इज each file system, each operating system is having its own file system number, and that is called as a logical device number. Like you people, so you all are acting as the students, but you are having roll number as a unique identification. So you all are students, but you are identified uniquely with the help of your roll number. In the same fashion, there will be more than one operating systems on one machine. So all are treated as operating system, but individual operating system is treated with the help of unique number, that is a logical device number. So this is about logical device number. This is the ninth field in case of in-core inode. Note it down. Then 10th field, the inode number. So each inode, in-core inode consists of inode number. So inode number is required when it is accessed at kernel level. So since inodes are stored in a linear array, internally inode कशा store केलेले आहेत, linear array fashion मध्ये store केलेले आहेत on the disk. The kernel identifies the number of disk inode by its position in the array. The disk inode does not need this field. So disk inode मध्ये हा field नाहीये, पण in core inode मध्ये हा field आहे. Because we are accessing the inode from disk to the kernel level, from the hardware level to the kernel level. So next field is inode number. Next, pointers to other in-core inodes. So actually, however, the buffers. So we discussed in the second chapter the concept of buffer cache, right? And in the buffer cache, number of buffers were there, and all these buffers are maintained either with the help of hash queue or free list. ते सगळे बफर कसे मेंटेन केलेले आहेत, एक तर ते फ्री लिस्ट चा पार्ट आहे किंवा हॅश क्यू चा पार्ट आहे, राइट. And both hash queue and free list, they are implemented with the concept of doubly linked list. It means each buffer is having its forward pointer and its backward pointer. In the same fashion, in-core inodes are also maintained in the form of list. So they are also maintained in the form of hash queue as well as free list. जे in-core inode busy आहेत ते सगळे hash queue वर ठेवलेले आहेत, आणि जे in-core inodes free आहेत ते free list वर ठेवलेले आहेत. So like buffer cache, inode cache concept is there. Like buffer cache, inode cache concept is there. So that inode cache consists of few in-core inodes and these inodes are maintained either with the help of hash queue or free list. So all the busy in-core inodes are kept on hash queue and all the free in-core inodes are kept on the free list. The kernel links inodes on hash queues and on the free list in the same way that it links buffers on buffer hash queues and on the buffer free list. जसे बफर कॅश मध्ये ठेवलेले आहेत तसेच इन कोर inode कॅश मध्ये ठेवलेले आहेत. So inode cache again it is the part of kernel level, right? So that's why each in core inode is having its own forward pointer and its own backward pointer. Forward pointer is pointing to the next in core inode in the free list or on the hash queue, and previous pointer of that in core inode is pointing to the previous in core inode of either hash queue or free list. जसं बफर कॅश मध्ये ठेवलेले आहेत हॅश क्यू किंवा फ्री लिस्ट मध्ये, तसंच इन कोर आयनोड्स ते आयनोड कॅश मध्ये ठेवलेले आहेत. आणि आयनोड कॅशचं कन्सेप्ट, आयनोड कॅशचं स्ट्रक्चर कसं आहे, सो इट्स सिमिलर लाईक बफर कॅश. In the second chapter, whatever we discussed with respect to buffer cache, so how the buffers are arranged, how the buffers are maintained, they are maintained either in the form of hash queue or free list. जे busy buffers आहेत ते hash queue वर ठेवलेले आहेत आणि जे free buffers आहेत ते free list वर ठेवलेले आहेत. तसंच inode cache मध्ये पण जे free in core inodes आहेत ते free list मध्ये ठेवलेले आहेत आणि जे busy in core inodes आहेत ते hash queue वर ठेवलेले. Okay, so this is the concept. So that's why each in-core inode is having two pointers. One is called as a forward pointer and another is called as a backward pointer. So forward pointer is pointing to the next buffer and backward pointer is pointing to the previous in-core inode. So like that, these are the pointers with respect to the in-core inodes. So this is about, so how many fields we discussed? 1, 2, 3, 4. Okay. Yeah, yes. So these four points, 4 additional fields we discussed as a part of in-core inode. And the total in-core inode fields kiti hai? Can anybody? How many fields are there in in-core inode? Yes, anybody? In-core inode मध्ये total kiti field hai? Come on. How many fields are there in case of in-core inode? Any student from the class? आपण टोटल किती फील्ड डिस्कस केले in-core inode मध्ये? मयूरी स्वामी. मयूरी स्वामी. वैष्णवी रोल नंबर 1. Vaishnavi Abhangrao.
Yes, ma'am.
So how many fields we discussed in case of in-core inode? Yes, Vaishnavi. किती फील्ड आपण डिस्कस केले in-core inode मध्ये? See, this is of no use. If you are just attending the lecture for sake of attendance, please don't attend. तुम्हाला फक्त अटेंडन्स साठी जर लेक्चर अटेंड करायचं असेल तर अटेंड करू नका. I will mark your attendance. Why you are attending the lectures? You are not listening to lectures. Nobody is responding to the lecture. Why you are attending the lectures? Yes, Vaishnavi Abhangrao, how many fields we discussed in core inode? I'm asking the same question. Nobody is answering. You were absent for the last lecture. Rutuja, 4 fields. So please correct yourself. I said whatever 7 fields we discussed in case of disk inode, so all these 7 are as it is applicable to in core inode. जे 7 field आपण disk inode चे डिस्कस केलेले आहेत ते 7 प्लस हे 4 म्हणजे टोटल 11 फील्ड आहेत इन कोर inode मध्ये. So total 11 fields are there in case of in core inode. Neha Kosti has given correct answer. So for your information, once again I will repeat. Note down. आपण आयनोडचा पॉइंट सुरू केलेला आहे. आयनोड मध्ये 2 प्रकारचे आयनोड आहेत. एका आयनोडला आपण डिस्क आयनोड म्हटलेलं आहे आणि दुसऱ्या आयनोडला इन कोर आयनोड म्हटलेलं आहे. जोपर्यंत तो डिस्क वर असतो त्याला डिस्क आयनोड म्हणतात आणि जेव्हा त्याला कर्नल लेवलला ऍक्सेस केलं जातं त्याला इन कोर आयनोड म्हणतात. तर डिस्क आयनोड मध्ये आपण मागच्या लेक्चरला 7 फील्ड डिस्कस केलेले आहेत. पहिला फाईल ओनर आयडेंटिफायर, दुसरा फाईल टाइप, तिसरा फाईल ऍक्सेस परमिशन्स, चौथा फाईल ऍक्सेस टाइम्स, पाचवा नंबर ऑफ लिंक्स, सहावा टेबल ऑफ कंटेंट्स आणि सातवा फाईल साइज. हे 7 फील्ड आपण डिस्क आयनोडला रिलेटेड आपण मागच्या लेक्चरला डिस्कस केलेले आहेत. आजच्या लेक्चरला मी म्हटलं की वी वर टॉकिंग अबाउट इन कोर आयनोड. तर त्या इन कोर आयनोड मध्ये किती फील्ड आहेत? सो इन कोर कॉपी ऑफ द आयनोड कंटेन्स द फॉलोइंग फील्ड्स इन ऍडिशन टू द फील्ड्स ऑफ डिस्क आयनोड. म्हणजे डिस्क आयनोडचे जे 7 फील्ड्स आहेत ते 7 फील्ड्स तर आहेतच इन कोर मध्ये, तर त्याच्या सोबत इन ऍडिशन अजून 4 फील्ड्स आहेत म्हणजे टोटल 11 फील्ड्स आहेत. ओके, दॅट्स व्हाय आय वॉज टॉकिंग दिस इज 8th फील्ड. जे 7 फील्ड आहेत अगोदर आपण डिस्कस केलेले ते 7 आहेत तसे लिहायचे इन कोर मध्ये. So in core inode and disk inode they are having first 7 fields common, and in core copy consists of 4 more fields जे की disk inode मध्ये नाही आहेत. That is nothing but status of the in core inode, logical device number, inode number and pointer to other in core inodes. Hope with this you cleared the concept. Yes, Vaishnavi, now clear?
Yes, ma'am.
Okay, so have you noted it down?
Yes.
Okay, now we'll proceed further. Under the same point we were talking about inodes. So we talked about 2 types of inodes. One is disk inode, another is the in core inode. Now we are discussing about management of inodes is similar to management of buffers. So however buffers are managed in the same fashion, inodes are also managed. The inode lock when set prevents other processes from accessing the inode. एखादा inode कोणतरी कुठली प्रोसेस ऍक्सेस करत असेल तर it will be locked. It will be locked so that other processes they are unable to access that inode. So other processes set a flag in the inode when attempting to access it to indicate that they should be awakened when the lock is released. जेव्हा प्रोसेस P1 ऍक्सेस करत असते आणि प्रोसेस P2, P3, P4, P5 जर वेट करत असतील, so they will be just in waiting state, and whenever process P1 will release that inode, so operating system should awaken म्हणजे जागा करणं. So operating system should awaken other processes, those who are waiting for that particular inode, that is P2, P3, P4, P5. ज्या काही प्रोसेसेस वेट करतात त्यांना वेकअप केलं पाहिजे ऑपरेटिंग सिस्टीमनं जेव्हा प्रोसेस P1 तो inode रिलीज करते. This is about management of inodes. So under management of inode, we are discussing about 2 types of inode. An inode is active when a process allocates it, such as when opening a file. जेव्हा आपण एखादी फाईल ओपन करत असतो तेव्हा त्याचा inode ऍक्टिव्ह असतो. आपण फाईल ओपन करतोय म्हणजे प्रोसेस ऑफ ओपनिंग इज गोइंग ऑन. जेव्हा फाईल ओपन होत असते त्यावेळेस त्याचा inode ऍक्टिव्ह असतो म्हणजे लॉक असतो. तो inode दुसऱ्या कुठल्याच प्रोसेसना ऍक्सेस करता येत नाही बिकॉज फाईल ओपनिंग is going on. Once the file will be opened, again that inode will be get released and it will be deactivated so that the inode will be given to other processes. So an inode is on the free list only if its reference count is 0, meaning that the kernel can reallocate the in-core inode to another disk inode. So inode कधी unlock असतो जेव्हा त्याचा reference count 0 असतो. Reference count in the sense त्याला कोणच रेफर करत नाहीये, कुठलीच प्रोसेस रेफर करत नाहीये. एखादी प्रोसेस रेफर करत असेल तर त्याचा रेफरन्स काउंट 1 असतो. So somebody is referring that inode. So reference count is 1. If two processes are referring, so I can say that inode count reference count is 2. If three processes are referencing that inode, reference count will be 3, like that onwards. So whenever that reference count becomes 0, it means nobody is accessing that inode. So it indicates that inode is totally free and it will be the part of free list. So the free list of inodes thus serves as cache of inactive inodes. म्हणजे थोडक्यात जे ऍक्टिव्ह आयनोड असतात ते हॅश क्यू वर असतात आणि जे इनएक्टिव्ह आयनोड्स असतात ते फ्री लिस्ट वर. So free list consists of all inactive inodes. In short, they are totally free. They are not busy with any process. And all the busy inodes are kept on the hash queue, indicating that they are currently busy with some of the processes. Something is going on that particular inode. That's why it is locked. Okay, so all the locked inodes will be as a part. All the locked inodes will be as a part of hash queue, and all the free inodes will be as a part of free list. So this is called as an active and inactive inodes. So all the active inodes will be on hash queue and all inactive inodes will be on the free list. This is about some management of the inodes. So under that, one of the two major management operations we are discussing. One is accessing inode and another is releasing inode. So here we are discussing about two algorithms. So for accessing inode, the kernel identifies particular inodes by their file system and inode number and allocates in-core inode at the request of higher level algorithms. The algorithm iget allocates an in-core copy of an inode. जसे की आपण बफर ॲलोकेट केलं. बफर कशाला ॲलोकेट करतो? जेव्हा एखाद्या रीडरला एखादी फाईल डिस्क वरून कर्नल लेवलला रीड करायची असते त्यावेळेस त्याला बफर लागतो. So we discussed one algorithm in the second chapter, that is get block algorithm. The same fashion here we are discussing about iget algorithm. So kernel gives one of the free in-core inode to the process, to the newly created file. So algorithm for allocation of in-core inode. जेव्हा एखादा डिस्क inode कर्नल लेवलला रीड केला जातो, मग डिस्क inode कर्नल लेवलला रीड करण्यासाठी in-core inode लागतो. राईट? जसं ब्लॉक डिस्क लेवलला रीड करण्यासाठी बफर लागतो, तसंच डिस्क inode हार्डवेअर लेवल मधून कर्नल लेवलला जर रीड करायचा असेल तर आपल्याला in-core inode लागतो. So how to get one of the in-core inode? So for that purpose we are taking the help of iget algorithm. So iget algorithm is somewhat similar like get block algorithm. Get block algorithm ना आपण बफर गेट केलेले, बफर कॅश मधलं. iget algorithm ना आपण in-core inode get करणार आहोत from the inode cache. So it is somewhat similar to the get block algorithm. Okay, so note it down the algorithm. First of all, we'll note it down the algorithm and then we'll proceed further. I will just minimize the size so that you are able to see the algorithm. So this is about iget algorithm. So purpose of the algorithm for allocation of in-core inode. Okay, so don't confuse. This is the algorithm for in-core inode. So for disk inode, another algorithm is there. Okay, so iget input will be file system inode number, output will be locked inode, actual body of the algorithm. So under the body, it is the size. Okay, so this is about the algorithm. You can zoom in, zoom out your screen so that you are able to write the algorithm. Algorithm iget, input file system inode number, output locked inode, while not done, जोपर्यंत in-core inode मिळत नाही तोपर्यंत. So this is the infinite while loop. If inode in inode cache, जो काही inode आपण ऍक्सेस करतोय तो जर ऑलरेडी inode cache मध्ये असेल So we are checking whether it is the part of hash queue or free list. So if it is the part of hash queue, it indicates that inode is busy. So that is, if inode locked, sleep event inode becomes unlocked. Continue. So which scenario is it? Can you guess? I said that this is algorithm. This is the algorithm which is totally similar to get block. फक्त गेट ब्लॉक मध्ये आणि याच्यामध्ये फरक काय, गेट ब्लॉक ना आपण बफर गेट करतोय आणि आय गेट ना आपण इनकोर आयनोड गेट करतो. Can anybody tell me which scenario is it? Here also these 5 scenarios are applicable. If inode locked, which scenario is it? Anybody? आपण टोटल 5 सिनेरिओ डिस्कस केलेले आहेत. कुठल्या सिनेरिओ मध्ये बफर कॅश मध्ये असतो, म्हणजेच हॅश क्यू वर असतो, पण त्याचं स्टेटस लॉक्ड असतं. In which scenario buffer status is locked? It is the part of hash queue. It is the part of buffer cache. Buffer cache मध्ये आहे तो बफर, पण त्याचा आयनोड फ्री नाही आहे, बिझी आहे. एनीबडी? हा कुठला सिनेरिओ आहे? Kernel finds the block on its hash queue, but its buffer is busy. Which scenario is it? उन्नती दायगुडे? उन्नती? Are you there? Yes, Unnati. Which scenario is it? बफर कॅश मध्येच आहे, पण त्याचं स्टेटस बिझी आहे. कुठला सिनेरिओ आहे? एनीबडी? Unnati, your mic is not working, but you can message, you can chat. Which scenario is it? Okay, let it be. So this is nothing but the 5th scenario. So if inode is in the inode cache, but it is busy, that is if inode is locked, inode cache मध्ये आहे पण तो लॉक्ड आहे, म्हणजे बिझी आहे. So this is nothing but about 5th scenario. तो जर बिझी असेल तर प्रोसेसने काय करायला पाहिजे, वेट करायला पाहिजे, स्लीप करायला पाहिजे. So sleep event inode becomes unlocked. Continue. Otherwise, so when it is not going to this loop, या लूप मध्ये तो कधी जाणार नाही जर inode free असेल तर. So if it is free, it will not goes to this loop. So if inode on inode cache free is on inode free list, free असेल तर तो कुठे असणार आहे, free list मध्ये असणार आहे. So remove from free list. This is about first scenario. This is the first one is nothing but the 5th scenario, and this is about first scenario. First scenario काय सांगतो, inode cache मध्येच आहे आणि त्याचं स्टेटस काय, फ्री आहे. So free in the sense it is the part of free list. This is about first scenario. Next, increment inode reference count. आता तो आपण inode काय करणार आहोत, फ्री लिस्ट मधून काढणार आहोत आणि त्याला ऍक्टिव्ह करणार आहोत, म्हणजे हॅश क्यू वर ठेवणार आहोत. So it will be busy. It will be busy with one of the process. In the sense, one of the process is referring that inode. So that's why its reference count will be incremented by 1. So initially it will be 0, now it will be incremented by 1. So that's why increment inode reference count. If it is 0, it will becomes 1. If it is 1, it will becomes 2, right, like that onwards. Return inode. So this is about if inode is in inode cache. Inode जर inode cache मध्ये असेल तर, buffer जर buffer cache मध्ये असेल तर either we are following first scenario or fifth scenario. Otherwise, so what will the else part of this? या if चा else part काय असणार आहे? If inode is not in inode cache. तो inode cache मध्ये असेल तर या गोष्टी करायच्या आहेत आपल्याला. त्याचा else ह्या लूप मध्ये तो कर्नल कधी जाणार नाही जर inode cache मध्ये नसेल तर, राईट. So if inode is not in inode cache, so what it does? It follows the remaining 3 scenarios, that is second, third and fourth. So if no inodes on free list, तो free list ला जाणार आहे. inode cache वर हॅश क्यू वर जर inodes नसतील तर एकतर ते हॅश क्यू वर असतात किंवा फ्री लिस्ट मध्ये असतात, राईट. It will goes to the free list. So in the free list also, so again this related to free list, 3 scenarios are there. So these are 3 scenarios. So here, if no inodes on free list वर जर inodes नसतील, so which scenario is it? Free list is empty. It's fourth scenario, right? So free list is empty. Free list empty असेल म्हणजे free list मध्ये एकही inode नाहीये. So what it does? It returns error. So this is somewhat different from the buffer. Buffer cache मध्ये काय केलेलं आहे आपण get block मध्ये तिथं वेट करायला सांगितलेलं आहे, स्लीपिंग स्टेट मध्ये जायला सांगितलेलं आहे. But here we are returning error because no in-core inode is there free right now. So don't wait because don't know when one of the in-core inode will be becoming free. So it totally depends upon the process. So that's why it returns error. So this is about the fourth scenario. हा fourth scenario आहे, तिथं मी कर्सर दाखवते. This is about fourth scenario. Next, ह्या लूप मध्ये तो कधी जाणार नाही fourth scenario च्या. So if free list is having some of the free inodes असतील free list मध्ये, so it will go to the next line. Remove new inode from free list, reset inode number and file system number, remove inode from the old hash queue and place it on new hash queue. So these 3 lines are totally related to the second scenario. These 3 lines are totally related to the second scenario. Second scenario मध्ये काय केलं आपण, free list मध्ये जर free inodes असतील तर पहिला inode काढलाय आपण free list मधून, सेकंड सिनेरियो नुसार त्याला रिसेट केलेलं आहे. जो inode आपण सर्च करतोय त्याच्याने रिसेट केलेलं आहे. And then we removed it from the old hash queue and we put it on the new hash queue. This is about second scenario. So this is about fourth. पहिला fourth बघितला आपण, त्याच्यानंतर second बघितला. And done. Read inode from this algorithm be read. Initialize inode, that is the reference count, is incremented by 1. Return inode, right? So this is about second scenario. And by default over here first scenario is there. पहिल्या scenario मध्ये काय केलेलं आहे आपण, सॉरी first scenario we discussed over here. पहिल्याच लूप मध्ये आपण पहिला आणि पाचवा सिनेरिओ कंप्लीट केलाय. इथं पहिले 2 सिनेरिओ आणि इथं उरलेले 2 सिनेरिओ. ऍक्च्युअली थर्ड सिनेरिओ इज नॉट ऍप्लिकेबल फॉर inode cache. इथं टोटल 4 सिनेरिओ आपण डिस्कस केलेले. जो डिलेड राईटचा सिनेरिओ होता तो inode cache ला ऍप्लिकेबल नाहीये. So this is about iget algorithm. Okay, so how to get one of the free in-core inode? So kernel takes the help of iget algorithm. Note it down, algorithm. Note down the algorithm. So still we are in the first point only. First point we are discussing about inode. Note it down. So all of you note it down, the algorithm. So iget is similar to get block. Only the difference is that in get block, we are getting one of the free buffer, and in iget, we are getting one of the free in-core inode. So both buffer as well as in-core inode are part of kernel level. This is about inode cache. inode cache मधून in-core inode access करायचे आणि get block मध्ये आपण buffer cache मधून free buffer access केला होता. Okay, so this is about iget algorithm. Hope you are noting it down. Write down the algorithm. Or you can note it down afterwards also. So let me cover one more point. Actually, okay, we'll discuss in the next lecture. Actually, two more formulas we are going to discuss. So in the today's lectures, you can just note it down. Algorithm iget. We'll stop here. After this algorithm, we'll not proceed further. So we'll discuss the next point. Actually, till we are in the inode, पहिलाच point discuss करतोय आपण या चॅप्टरचा inode. आणि त्या inode मध्ये आपण दोन टाइपचे inode डिस्कस केले. एक डिस्क inode, दुसरा in-core inode. आणि त्याच्यानंतर हा अल्गोरिदम आपण डिस्कस केलेला आहे. अजून एक अल्गोरिदम आहे ह्याच पॉइंट मध्ये आय पुट म्हणजे आय गेटच्या अपोजिट. जेव्हा in-core inode जर गेट करायचं असेल तर आय गेट अल्गोरिदम, आणि जर तो रिलीज करायचा असेल तर आय पुट अल्गोरिदम आपण वापरणार आहोत. सो ऍक्च्युअली वी आर नॉट युजिंग ऑल these algorithms are used by the kernel. Okay, so in this lecture this much is sufficient. Algorithm iget. So note it down, the algorithm. If it is over, writing is over, you can drop the message in the chat box writing your roll number or attendance. And if your writing is over, you can leave. Algorithm write करून झाला असेल. If you are not having any kind of doubt, you can just drop your roll number as a part of attendance and you can leave. So in the coming today's practical, so I am taking the second practical. I request all of you. So first of all, you have to join to the lecture. I will explain the practical, how to do it. Then you have to implement that practical. आजच्या प्रॅक्टिकल मध्ये मी मला एक्सप्लेन करते प्रॅक्टिकल कसं करायचं. सो सेकंड प्रॅक्टिकल वी आर डिस्कसिंग. Second practical is related to copy command implementation. So some of the students, they have already implemented while they attended the offline classes. So those who have not implemented, or you all join and we'll discuss, and then you can implement. So before that, I request all of you install Linux operating system on your laptops. You can come to college. ज्यांच्याकडे लॅपटॉप नाही आहे ते कॉलेजमध्ये येऊन कॉलेजमधल्या मशीनवर बसलात तरी चालेल. कॉलेजमध्ये मॅक्झिमम मशीनवर सीसी लॅब मध्ये आपण लिनक्स इन्स्टॉल करून घेतलेला आहे. So over there you have to take the help of terminal and you have to implement the commands. So now we'll stop today here. In the afternoon period, our practical is there. At that time, I will tell you, I will explain the practical, then you have to implement. Okay, so we'll stop here. Thank you.